Welcome back to Java Internals Crashcasts. I'm Sheila, and today we're continuing our journey through the fundamentals of concurrency. We're in the Thread Basics chapter, and we'll be diving into the fascinating world of thread lifecycle.
That's right, Sheila. In our last episode, we covered creating and starting threads. Now, we'll explore what happens to a thread throughout its existence. This knowledge is crucial for anyone working with programs that can do multiple tasks at once in Java.
Absolutely, Victor. Before we jump in, let's start with a quick quiz for our listeners. Here's the question. Which thread state is not directly accessible through the thread? State enum in Java. Think about it, and we'll reveal the answer at the end of the episode.
Ooh, that's an intriguing question, Sheila. It really makes you think about the different states a thread can be in and how Java represents them. I'm sure our listeners will be pondering this throughout the episode.
Now, Victor, could you give us a brief overview of what we mean by thread lifecycle?
Certainly, Sheila. The thread lifecycle refers to the various states a thread can be in during its existence, from creation to termination. Understanding this life cycle is crucial for effectively managing threads and fixing issues in programs that use multiple threads.
That makes sense. So, what are these different states a thread can be in?
Great question. In Java, a thread can be in one of 6 states: new, runnable, blocked, waiting, timed waiting, and terminated. Each state represents a different phase or condition of the thread's life.
Wow, that's quite a few states. Could you break them down for us?
Of course. Let's start with the new state. This is when a thread has been created but hasn't started running yet. Think of it like a newborn baby who hasn't taken their first steps.
That's a helpful analogy. So, what happens next? How does a thread move from new to actually doing something?
The thread moves to the runnable state when we tell it to start. In the runnable state, the thread is either running or ready to run when it's given a chance. It's like an adult going about their daily activities.
I see. But threads don't always keep running, right? What other states can they transition to?
You're absolutely right, Sheila. A thread can enter the blocked state when it's trying to use something that's being used by another thread. It's like waiting for a busy bathroom. You can't proceed until it's free.
That makes sense. What about the waiting state? How is that different from blocked?
The waiting state occurs when a thread is waiting for another thread to do something specific. It's like waiting for your friend to arrive before starting a movie night.
And timed waiting? I'm guessing it's similar to waiting but with a time limit.
Exactly. Timed waiting is when a thread is waiting for another thread to do something, but only for a specific amount of time. It's like setting a timer while waiting for your friend, and if they don't show up, you start the movie anyway.
That's a great explanation, Victor. What about the final state, terminated?
The terminated state is when a thread has finished its job or has been stopped. It's like finishing a marathon or retiring from a job. Once a thread is in this state, it cannot be restarted.
Now that we understand the states, could you tell us about some common problems developers might face when dealing with thread life cycles?
Certainly, Sheila. One common issue is deadlock, where 2 or more threads are stuck forever, each waiting for the other to release something they need. Another is race conditions, where the program's behavior depends on the timing of events, which can lead to unpredictable results.
Those sound tricky to fix. Are there any best practices to avoid these issues?
Absolutely. Some key practices include: 1. Always getting resources in the same order to prevent deadlocks. 2. Using tools from Java's concurrency package instead of low-level synchronization. 3. Avoiding holding onto resources during long operations. And 4. Using data structures that are safe for multiple threads when sharing information between threads.
Those are great tips, Victor. Now, here's something I've been wondering about. I've heard that telling a thread to sleep for 0 milliseconds can be used to let other threads have a turn. Is that true? And if so, how does it work?
That's an interesting point, Sheila. Yes, it's true. When you tell a thread to sleep for 0 milliseconds, it gives up its turn and goes to the back of the line for threads of its level of importance. It's a way to give other threads a chance to run, especially in situations where a thread is constantly checking for something. However, it's generally better to use more specific tools for managing when threads run.
Fascinating. As we wrap up, let's reveal the answer to our quiz question. Which thread state is not directly accessible through the thread? State enum in Java.
The answer is the running state. While we often talk about a thread as running, Java doesn't distinguish between a thread that's actually running on the computer's processor and one that's ready to run. Both are represented by the runnable state.
That's a great point to remember. To summarize today's episode, 1. We learned about the 6 thread states: new, runnable, blocked, waiting, timed waiting, and terminated. 2. We discussed how threads move between these states and what causes these transitions. 3. We covered common problems like deadlocks and race conditions and best practices to avoid them. And 4. We learned an interesting fact about using sleep or 0 to let other threads have a turn.
Excellent summary, Sheila. In our next episode, we'll be diving into how Java decides which threads to run and when, which will give us even more insight into how Java manages thread execution.
Thanks for tuning in to Java Internals Crashcasts. If you found this episode helpful, please subscribe and leave us a rating. Your support helps us continue creating in-depth content on Java Internals. Until next time, happy coding.